Hello, thanks for watching the video and studying your math with us. These videos serve to accompany but not replace reading in your textbooks, so don't ignore that, please. This episode offers a little review of some of the materials contained in Chapter 1.1. We will, of course, be dealing with numbers, and some vocabulary is useful. The counting numbers, 1, 2, 3, and so on and so forth, are called natural numbers. Adding 0 to this set, we get a larger set called the whole numbers. And adding the negatives of the natural numbers, we get an even larger set called the integers. Next, we add some numbers to reflect not only whole numbers and their negatives, but fractions thereof. This involves the ratio of integers and therefore is called rational numbers. These can either be fractions, either improper or proper, like 5 over 9 or even 9 over 5, can be negative like minus 3 over 8, and can be represented, all of them, as either terminating, like 4.72 that terminates with the 2, or infinitely repeating sequences like this 0.6666, which ends up being 1 2/3 as a mixed number. It's useful to note that every integer can be a rational number because minus 2 is really minus 2 over 1. There are real numbers, however, that do not have terminating or infinitely repeating decimal sequences, and those are called irrational numbers. Example would be pi, the square root of 3, square root of 5, or the square root of any prime number. These are not rational numbers, and therefore they're called irrational numbers. This is the first time we've created a suite of numbers that did not contain the previous set. Together, the irrational numbers with the rational numbers form a set called the real numbers. Since squaring a real number always results in a positive value, or 0, the square roots of negative numbers are not real, and even though they do exist in your technical work, they're called imaginary numbers. There is no real number whose square that serves as the square root of minus 4, and there's no number, for example, that serves as the square root of negative 7. The real numbers possess an ordering and therefore can be positioned on a number line. All of them, including irrational numbers and rational numbers. Each has a place on this number line. A special place is assigned to 0. That's called the origin. The negative numbers go out to the left and the positive numbers go out to the right in the appropriate order. We have additional terminology and notation that deal with this ordering. Sometimes we will speak about the absolute value of a number, denoted by these two bars. The absolute value of x really means how far is x from the origin or 0 point. So the absolute value of minus 7 is going to be 7 because minus 7 is 7 units away from the origin. Similarly, the absolute value of minus 6 is 6 because 6 is 6 units away from the origin. We can say A is greater than B means that A is to the right of B on the number line. Similarly, we can speak about calling less than and less than or equal to and equal to in dealing with this order on the real number line. Here's some practice problems. You should hit pause on YouTube. Do the problems and then hit YouTube play when you're done to check your work. Narrated solutions will follow. Okay, I'm back. Let's see how you did. The answer should have been 4.2, negative 3/4, and minus 5 is less than 4, and 0 is greater than minus 3. Get help on these if you did not get the correct answers. Some more vocabulary, a big word called reciprocal. Every number except 0 has a reciprocal, And the definition is the reciprocal of a number is 1 divided by that number. You might ask what happens with 0. Well, your calculator will give you an error result because you can't divide by 0. As a joke, it shows you Chuck Norris here, but not even Chuck Norris can divide by 0. Chuck Norris will, however, be the answer to a preparation audit quiz the next class period, so watching the video will earn you some points that way. Again, some more practice examples. Hit pause, do the problems, and return to narrated solutions to check your work. Okay, we're back. Let's see how you did. So you should have gotten -1/4 and 8/3 as your answers. Get help if you did not get these answers. Many times in technical work we will have units associated with our answers. In your textbook they call these denominative numbers. Your answers are not complete without proper units, and points will be deducted. Moreover, as this NASA example indicates, failing to properly handle units can be catastrophic. I also recommend that you look at Appendix B. It will not be the last time that we go there. Finally, we often find letters in formulas and such. These are called literal numbers. They can either be variables or they can be constants. A good example of this comes from the equation you remember from your algebra, the slope-intercept form of the equation of a line. Here we have a whole bunch of letters, but the x and y represents variables, points in the xy plane, and for a given line, m and b are constants representing the slope and the coordinate of the y-intercept, the y-coordinate of the y-intercept, respectively. That's it for Chapter 1.1. Remember, time is precious. Each day must count. Do the math. It will make you strong. See you in class.